The amazing thing about the universe is that everything you can see here, from the Big Bang up until the stars and galaxies we have today, can be described by four fundamental forces. On one hand, this is amazing because you have all this complexity, but you can describe it so simply. On the other hand, you might wonder what would happen if there were other fundamental laws. Would you have different universes with different discoveries to be made? This is the world of quantum materials research, where each material we study acts like its own universe with its own physical laws and its own discoveries to be made. This is graphene. It's a perfectly atomically thin sheet of carbon atoms, perfectly two-dimensional. It lets us ask questions about the universe, like what would happen if the universe was completely flat instead of the three-dimensional universe we live in. In this case, electrons move around in graphene like they have no mass at all. They just hop from carbon atom to carbon atom effortlessly. This is a superconductor, and it's able to levitate a magnet above it. This is a quantum material where inside the superconductor, light moves as though the photon has mass. Now, in our world, nothing travels faster than light because photons are massless. But quantum materials, this can be different. In this case, photons have mass. Doing fundamental quantum materials research is like being an explorer. Why do we do it? Well, because it's there, because it's exciting. But quantum materials research also drives technology. So this is silicon. Silicon was discovered over 200 years ago, and it took decades of fundamental research to turn it into the information technology and semiconductor industry that we have today, powering everything from the chips inside your cell phone to the solar panels on the James Webb Space Telescope. Superconductors aren't as far along in the technological pipeline as silicon is, but we're still studying them. But all of the wire inside an MRI machine is made of superconductors, and the quantum computers being developed by IBM and Google are also made of superconductors. Fundamental research is never done by one person alone. So here's my team of explorers, and we specialize in building experiments that take materials to their extremes. So we cool them down to temperatures just a few thousandths of a degree above absolute zero. We travel to national labs to put them in magnetic fields that are 1,000,000 times stronger than the Earth's magnetic field. We use those strong fields to really push electrons around and test the fundamental limits of nature. We use ultrasound to peer inside of superconductors and discover new types of superconductivity. We work with groups at Cornell who have powerful microscopes that can look at individual atoms and find where each atom is placed inside a quantum material. Materials have been so important for humanity that we name each age after one. We have the Stone Age, the Bronze Age, the Iron Age, and now we live in the age of silicon. We know that quantum materials are going to power the age of tomorrow, and really the question is, which material will it be?